Hello, math friends. Welcome to A Squared Math and Stuff. This example is going to focus on matrix multiplication. I'm going to walk you through two methods of organizing your work for matrix multiplication because this can get pretty messy, I would like to say. Before we get into the process of how exactly we multiply two matrices together, I want to talk to you about the requirements in order to multiply. The first thing is, and the most important thing is, that the number of columns of the first matrix that we are multiplying needs to equal the number of rows in the second matrix that we are multiplying. And the resulting matrix is the dimensions of the number of rows of matrix A by the number of columns of matrix B. So that might look pretty complicated because we're working with variables in there. So let's go down here a little bit and we can see some numbers. I know there's a lot of variables and numbers in here as well, but I'm going to get into an example here in just a moment. So bear with me. In this first example, or in this first matrix, actually, this is a 2 by 4. We have 2 rows and then 4 columns. The matrix it's being multiplied by is a 4 by 3. So 4 rows, 3 columns. These two inner numbers, I like to call them the inner numbers because when we connect these, they're the same. That means that we can multiply these two matrices together. The resulting matrix is the outer numbers, the 2 and the 3. So our final answer is going to be a 2 by 3 matrix. The process on how to calculate this 2 by 3 matrix is we take our first matrix and we focus on a row and we multiply and add to the second matrix column. So we're going across the first and down the second matrix at the same time. And the formula is written up here. And what we will end up doing is we take this first row, column 1, multiply it by first row, column 1 of our second matrix. So we'll have A11 times B11. And then we follow this process. We go row 1, column 2, multiply though by row 2, column 1, and then we will do row 1, column 3, row 3, column 1, and then finally multiply this last value, row 1, column 4, by row 4, column 1, and we add those all together. And we continue this across and down process until we have all 6 spots. I know that's really confusing and that's really quick and it's all in a nutshell. So let's just jump to examples because it's easier to see what's going on when you have numbers in front of you. This example, like I said, I'm going to show you 2 different methods to solve this. And the first method is very similar to what you just saw on this page here. There's not a whole lot of organization, but we're going to go ahead and do it this way. So we need to see first, can we multiply these matrices together? This first matrix is 2 rows by 3 columns, and the second matrix is 3 rows by 2 columns. These values are the same, so we can multiply this. And these next values, the 2 and the 2, this is the resulting matrix. This is the dimensions of our final matrix. So dimensions of final matrix. If you get something other than a 2 by 2 matrix for your final matrice, you did something wrong somewhere. All right, let's get into this. So the process that we just looked at says that we are going to focus on row 1 of our first matrix, matrix A. We're going to work across row 1 at the same time as going down column 1. And we're going to multiply the first numbers of each of these and add it to the multiplication of the second numbers and add it to the multiplication of the third number. So going across and down at the same time. So So I like to work with 2 fingers here and have one go across and one go down so I can organize my thinking and I know what numbers I'm working with. All right, let's set this up. Row 1 and column 1, I'm going to end up with, I have 6 times my -3. I'm going to add that to my second number in each row and column that I'm looking at. So I'm adding that to a -5 times a +5. Now I'm going to move my fingers across and down again, and I'm going to add the product of those two numbers. So I'm adding a -6 times 1. Now I'm going to do the same thing, but I'm going to stick with row 1 and I'm going to go down column 2. So I'm working with row 1, column 2, which means I'm going to have the sum of my products in row 1, column 2. Let me scoot over a little bit here so hopefully I can fit this all in here. All right, I'm again going to work with going across and down with my fingers at the same time so I can keep my numbers organized. So I'm working with a 6 and a -1. I need to multiply those. 6 times -1. I'm adding that to the second number in the row and the column. So a -5 times 4. I'm going to write a little smaller so I can fit it all in. Move my finger across and down, and then I have to add to a -6 times 0. So I'm done with row 1. Now let's focus on going across row 2. So I'm going to go across with my finger on row 2, but now I'm going to revisit column 1 because I need to multiply row 2 and column 1 in order to get the values that go in row 2, column 1. So putting my fingers in position, I have 6 times a -3. Go across and down. I'm going to add 4 times 5 across and down, add a -1 times 1. So that completes row 2, column 1. Let's go to row 2, column 2. So focusing on row 2, then go down column 2. So I will have 6 times a -1 plus 4 times 4, and finally plus -1 times 0, and close off this matrix. Now what we want to do is go ahead and multiply each of these numbers out. So let me move this up. We will multiply each of those out, and focusing here on row 1, column 1, we have 6 times -3 gives us -18, plus -5 times 5 is a -25, plus -6 times 1 is -6. Moving over to row 1, column 2, I'll have -6 minus 20 plus 0. Go down to row 2, column 1, we have -18 plus 20 minus 1. And then again, row 2, column 2, -6 plus 16 plus 0. Close that off. Now let's add these all together, and that will be our final matrix there. So a -18 minus 25 minus 6 gives us -49. -6 minus 20 plus 0 equals -26. -18 plus 20 minus 1 gives us 1. And then finally, we will end up with a 10 there. So that is our final matrix, and it worked out to be a 2 by 2, which is exactly what we were supposed to get based on the dimensions of the final matrix here. The second method I'm going to show you is the exact same process, because this is the process that we need to use in order to multiply matrices out. It just sets it up a little bit different. We're going to do the exact same multiplication so that you can see it works out exactly the same, but I'm going to start it out and set it up a little bit differently. I'm going to take this first matrix and set it up just right down here. 6, -5, -6, 4, oops, it's not a 4, that's a 6. So 6, 4, -1. And I'm going to take the second matrix and I'm going to set it up like kitty corner below and to the right of the original, or I'm sorry, the first one. And I'm going to space it out because I want to have room to write. So just bear with my spacing here so that I can show you exactly what we're doing. So -3, 5, 1, put this way over here to give me more room to write. Once you understand the process, you don't necessarily have to space this out this much, but again, I'm showing you the process on how to do it. What I'm going to do now is I'm going to extend the top and bottom of this matrix A, the first matrix, and I'm going to draw a line between each row. And then I'm going to do the same thing for my second matrix. So I'm going to extend this up and then draw a line in between each column. So what ends up happening is this turns into our final matrix. We are going to have this matrix with the dimensions of a 2 by 2, and that's what we should have. This will be our row 1, column 1, row 2, column 1, row 1, column 2, and row 2, column 2 values. Let's see how we ultimately do this. By creating this little grid system here, it helps to keep everything organized because I can see that I'm going across and I can see that I'm going down this column because these are where these rows intersect. So for many people, this works out better because it's more of a visual and a guide. We still, however, need to multiply those first values of the row and the column, the second value of that row and column, and third value of that row and column together and add all their products. So the process is exactly the same. As I said, it's just set up a little bit differently to keep things organized, and you don't have to use your fingers to go across and down. So 6 times -3, -5 times 5, we have to add the products, and then plus a -6 times 1. So that's our row 1, column 1, and it helps me to understand that it goes in that position with this grid system. So let's do row 2, column 1. 6 times -3, 4 times 5, and then plus a -1 times 1. And now jump up to row 1 and then column 2. 6 times -1 plus a -5 times 4 plus a -6 times 0. And finally, row 2, column 2, we go across and down. 6 times -1 plus 4 times 4 plus -1 times 0. And when we work this out, we should get the exact same values that we got on our previous example. We should end up with a matrix that looks like this once we multiply those out with a final answer that's exactly the same. Working those out, we then get -18 minus 25 minus 6, and then we will get -18 plus 20 minus 1. We'll have -6 minus 20 plus 0. And lastly, negative 6 plus 16 plus 0. And we get the exact same answer, which happens to be a negative 49, negative 26. Row 2 is 1 and 10. 2 by 2, same values, just setting it up a little bit different. So that's how you multiply matrices together. If you like what you saw, go ahead and hit that subscribe button down below. I do have another video that has a couple more examples in it. So if you're interested in that, go ahead and check out the next video.